Algebra 2 Honors, Chapter 14, Lesson Trig Modeling. So, big question, why bother with all this graphing? And the answer is so we can, model the world. And in this case, we want to model what we call sinusoidal phenomena, anything that cycles. Daylight, the amount of daylight, daily temperatures, tides, lots of choices, lots of options. So let's practice an easy one. We've got this beautiful looking model here. And we look and we say, the middle is right about there. So that tells us our vertical shift is 2. And it goes up as high as 4 and as low as 0. It tells us our amplitude is 2. And we look at it and say, it looks like a sine curve that starts right about here and ends here. So our period is 5 pi over 4 minus pi over 4 equals pi. And our horizontal shift, it went over pi over 4 to the start. More on that a little bit later. So we use that. And these were our 4 choices: vertical shift, amplitude, period, horizontal shift. And you can start with whatever you want. I happen to start with vertical shift because it seemed obvious to me. Let's use all this data to make the equation of the line. Y equals 2 sine theta minus pi over 4 plus 2. To figure out what goes in here, well, we know that's the b value. It's just a label we give it. It doesn't matter. You could use any letter. We know it equals pi. So do a little math here, and we say, oh, obviously b equals 2. So there's our equation. Now the next question I ask is, can we check it? And of course we can. One of the great ways to check it is by plucking a point off. Let's take this one here. This is the point 5 pi over 4, comma 2. So plug that in and see if we get what we're supposed to get. So 2 times sine of 2 times 5 pi over 4 minus pi over 4 plus 2. 2 times 5 pi minus 4 is pi. 2 pi, sine of 2 pi is 0, plus 2 equals 2. And that is what we're hoping to get. So our model works. Several people point out, well, what if I wanted to make this cosine? Well, cosine starts up here, so then your horizontal shift would just equal pi over 2. Otherwise, same equation, just put cosine in for sine. You could even make it negative sine start here, where your horizontal shift would be 3 pi over 4, or make it negative cosine, where your horizontal shift would be negative pi. Got all these options. Doesn't really matter. Way too easy. Let's make our lives much more difficult. If you've never seen it, Bay of Fundy, go to YouTube and just look at any time-lapse video of the tides. They go up and down like 40 or 50 feet. It's pretty cool. You'll see boats sitting in the mud and then they're in 20 feet of water. It's wild. So I'm going to make a very quick and dirty graph. And my scale is purposely a little bit goofy. So we've got a problem here at 12 a.m. 2. You can't start at 12, so we have to call this 0. We'll leave 12 p.m. at that. We're up here at about 2.55, and then 2, 4, 6, 8, 10, 12. Like I said, a quick and dirty graph. 3.8 here, 4.4 here, 3.8 here, 2.55 here, 10, 1.8, 2.27 here. Definitely looks like a sinusoidal graph. So we look at it and we say, well, what can we pluck off? Well, we want to find the vertical shift here in the middle somewhere. The other data was kind of manufactured, the other graph that we used. This one, we've got to go to the high and the low. And those are not necessarily the high and the low. They might just be the data we have every 2 hours. But we got to start there. And basically, the vertical shift means halfway between the high and the low, which if you've never done is very simple average. And the amplitude is how far away we are from that. So it's 4.4 minus 3.1, or it's 3.1 minus 1.8. Either way, you get 1.3. Period's a little trickier to figure out. The projects I'm going to have you do, the period's usually 1 year because you're finding temperature over the course of a year, which means it's repeating every January 5th. It's roughly the same, and every August 2nd, it's roughly the same. But for here, we're going to look at half the distance from crest to trough. And double it. All right, so this is 6 hours. So the period is 2 times that. It's 12 hours. A lot of people struggling with that. So I don't know what to say. Just be aware of it. It's tricky, no question about it. And then we have that whole 12 over b equals 2 pi. Pardon me. 2 pi over b equals 12. So b would equal pi over 6. Remember, we're trying to set up an equation here. Just for future purposes, this point is 4, 4.4. And we need that because we've got an equation set up quite nicely. Y equals 1.3. We'll go with sine. Just figured this one out. Pi over 6. Theta. We don't know what this is. We'll just give it an x for now. Plus 3.1. So we're going to take that point, 4, 4.4, and we're going to plug it in. 4.4 equals 1.3 sine pi over 6 theta plus, 4 plus x, 3.1. Subtract 3.1 from both sides. Divide 1.3 from both sides. We get up here with 1. 1 equals sine of all this nonsense. Pi over 6. 4 plus x. How do we get rid of this sign? Hopefully remember, sign in the negative first of all of it. Sign in the negative first of this side. If you don't remember how to do sign in negative first, this is good review. I don't do arc sign, sign the negative first, I say, where does sine equal 1? And that happens to be on a unit circle right up here. So some people say, oh, you mean 90 degrees? I say, no, we mean pi over 2. Because when you do a real life application, it has to be done in radians. Make sure your calculator's in radians when you do this. So now we get rid of the signs, the magic unplug the inside of the sign from the sign trick. Pi's are going to cancel. Multiply both sides by 6. You get 3 equals 4 plus x. X equals negative 1. So our equation is y equals 1.3 sine pi over 6 theta minus 1 plus 3.1. And if we look at this, that's our horizontal shift. It's about 1. It looks like it's about 1. That's how far over we went till we get to the start of our sine graph. So what's going to be at 3 p.m.? Also known as 15 hours. Can't repeat to 3. It'll give us 3 a.m. So we plug all this in. Blast it out. Make sure your calculator's in radians. And see what you get. I'm not going to do it for you. It should match up nicely with what you would expect to see on your graph. So take it from there. For those who haven't done their modeling projects yet, pick daylight or temperature somewhere in the United States or somewhere in the world. Singapore, Hong Kong, somewhere really warm, somewhere really cold. And you should be able to find data. Take the 1st of the month, the 15th of the month, the average for the month, the average amount of daylight, the average temperature, the average high temperature, and just map it out. Then go ahead and find your vertical shift, your amplitude, your period, all the way down to your horizontal shift, like we just did, and see if you can model it. That's it. There's a lot of information here. Good luck.